Hello students, welcome you to this session. In today's class, I am going to teach some of the sums from exercise 1.3, what we left out. Very simple sums only. Now let us see the sums one by one. First we start with sum number 5. Let A is 1, 2, 3, 4 and B is A, B, C, D. Give a function from A to B in each of the following. So now some conditions given, based on that you have to form a function. So you cannot mug up anything here. So with understanding you can do that. So we have to give function. So it should be a function, right? So for our convenience, just I am drawing like this. But later we write it as a set of ordered pairs. A is a set 1, 2, 3, 4. And B is A, B, C, D. It is a function, so every element must have image, right? But what they said here, neither one-to-one nor onto. So it is not one-to-one. It is not one-to-one means more elements are related to one element, right? It is not 1-1. So 1 is related to A. Suppose 2 also related to A means now itself it is not 1-1, right? It is not onto. Not onto means some elements has no pre-image. Some elements should be left out in the second set, right? In the second set B. Okay, now the remaining just I am giving like this. So now one element D has no pre-image. So it is not 1-1. It is not onto also, right? So codomain and range, they are not same. So you can write as say R1, I am taking like this. Or you can say it's a function, right? So you can use the letter F1. Any letter you can give. F1. So 1 is related to A, 2 is also related to A, 3 also you can relate with A, nothing wrong in that, right? So here I am taking 3 related to B and 4 related to C or D. I am giving here C. Okay, so this is an example for the function which is not 1-1, also it is not onto. See the second one. Again for the same sets. So A is a set 1, 2, 3, 4 and B is a set A, B, C, D. We have to form a function. It is not 1-to-1, not 1-to-1, not 1-to-1 means okay, at least 2 elements must have the same image. It is, but onto, it must be onto. So now 3 related to B, 4 related to C. It is not onto, right? Some element left out. If we have some more number here, okay, then you can relate with D. So it is not there. And that D is there. If D is not there, okay, it is not onto. But here you cannot frame. So for the second one, your answer is not possible. So they asked to form not 1-1. Okay, it is not 1-1, but onto. So it cannot be onto also. Okay. For the next one, same thing, we take 1, 2, 3, 4 domain and the codomain is A, B, C, D. So first set A, second set B. 1-to-1. So 1-to-1 means every element related to one element only, right? So 1-to-1. Okay, it is 1-to-1. But not onto. So here no element left out. If there is one extra element left out, you say it is not onto. So it is 1-1 means here 4 elements, here also 4 elements. So every element related to different element related to different, every different element has different images. So no element left out there. So it is onto. It is not onto, not possible. So you say for this also the answer is what? Not possible. Because number of elements in A is equal to number of elements in B. So one element related to one element, every element related. Okay, no element left out. Okay, see the last one. A is 1, 2, 3, 4. B is A, B, C, D. 1-to-1, 1-to-1, and onto. Yes, it is onto only, right? This is the answer for this one. 1, A. You can change the answers. 1 is related to B, 2 is related to A. You can change anything. 1A, 2B, 3C, 4D. So the answer what you are writing, check whether it satisfies both the conditions. It should be 1-to-1 and onto. Okay, so this is another function. So I'm taking this function as what, f2. So 4 subdivisions, in 2 of them not possible, other 2 you got the answer. Okay, now let's go for the next question. Show that the relation xy equal to minus 2 is a function for a suitable domain. It is a function for a suitable domain. Find the domain and range of this function. Okay, so xy is equal to minus 2, xy is equal to minus 2. So find y from here, y equal to minus 2 by x. It is a function. It is a function, but it exists for every element other than what? 0. Because if the denominator is 0, then you say the function does not exist, right? But suppose the denominator is x minus 3, you say it exists for every element except what? 3. Excluded element in 10th standard you have studied, right? So here it is minus 2 by x. So it exists for every element except when x equal to 1. So, okay, show that the relation is a function for a suitable domain. It is a function, and the suitable domain also you mentioned. So here the domain is, you can give any real number other than what? 0. Because if you give 0, something by 0 not defined, right? And they asked to find the range also. Range means y value, right? The answer. Domain, what values you can give for x, that is domain. And range means the answer. When you give x some value, so you are giving for x what value you are giving? You can give any value from here, right? You can give any real number other than 0. You are giving a non-zero number. When you give a non-zero number, your answer is also a non-zero number. Your answer is also a non-zero number only. So the range is also any real number other than what? 0. Okay. So for the examination, this is enough. But for you to understand more, just I'm giving a graph. Actually, this is a graph for xy is equal to some positive constant. Xy is equal to, suppose it is 2 or something. But here they given xy is equal to minus 2, right? So it will change the position, I'll tell you. If xy is equal to 2, this is the graph, and this graph we call it as rectangular hyperbola. It is called what? Rectangular hyperbola. So what is the domain here for x? You can give any value. Any value you give x, yes, the function exists. But when you give 0, the value does not exist. The corresponding y value will be infinity. It never touches very close to that. Okay. So that is why the domain is any real number other than what? 0. Okay. So the range is the y values. So here and all, these are the y values, right? These are the y values. But here alone, the y value is not there, right? So when x is 0, it is not there. So range is r minus 0 for this question also. Suppose instead of xy equal to positive value, xy is equal to some negative value, the curve will come this side. Okay, this side and this side. So this is the curve will be like this. This is xy is equal to minus 2. Here also, you can't give x equal to 0, right? When you put x equal to 0, the corresponding y value will be infinity only. Okay, so you know, so it does not exist when x equals 0. So the domain is any real number other than 0. Range, the answer is all. This is your answer. Okay, the curve is the answer. So curve exists everywhere except what? 0. And 0, there is no curve at all. So the range is r minus 0. Okay, so this just for you to understand. For the examination, you don't need to draw any graph. They didn't ask that. So this is enough for the examination. Okay. So now look at this question. Okay, before doing this sum, just let me explain. The modulus x, absolute value, already you studied that. Modulus x means it has two values. Modulus x is x when x is positive, and it is minus x when x is negative. Here you can give greater than 0 also, greater than or equal 0, because when modulus of 0 is what? 0 only, right? 0 can be added with any one time, either for the first range or for the second one. So modulus x has two values. It is plus x when x is positive. It is minus x when x is negative. Okay, so now please listen here. With that idea, here they said f of x, modulus x plus x, and g of x is modulus x minus x. We have to find g composition of f composition. Last class I taught composition of functions, so it will be very easy only. But because this modulus is there, so listen very carefully. Okay, so I'm going to take in two cases. So first case I'm take case 1 when x is positive. When x is greater than 0. You know, when x is greater than 0, modulus x is equal to what? X. Modulus x is equal to x. X is greater than or equal to 0. So in that case, can you say what is f of x? Modulus x is what? X. Modulus x is x. So this is x. Plus this is also x. So x plus x. So what's your answer? It is what? 2x. So f of x is 2x. And what is g of x? G of x. So see the question. It is modulus x minus x, right? Modulus is only for the first one. Okay, here the modulus x is equal to what? X. Modulus x is x. So you are getting x minus x. So your answer is what? 0. G of x is equal to 0. So when x is greater than or equal to 0. So we have to find g composition f. So let us find g composition f. For that you find g composition f of x. So that is g of f of x. That is g of, what is f of x? 2x. Put this value in g. What is g? It is 0. So 0 and anything, it is what? 0 only. Okay, so the answer is 0. This is g composition f. Now we want f composition g also. So f composition g of x is f of g of x. That is f of, what is g of x? 0. So put this 0 in f. That is 2 into x, right? 2 into 0. So that answer is also 0. This is in the first case when x is greater than or equal to 0. Now the second case, when x is less than 0. Why we are taking two cases? Because modulus x is there. Modulus x has two values. So in each case you have different fx and different gx, right? So in this case, let us see what is fx and what is g of x. Modulus, sorry, when x is less than 0, when x is less than 0, modulus x is minus x, right? So what is fx? You see, modulus x is minus x. So minus x plus x. So fx value will be 0. Fx value will be 0. And gx value, modulus x is minus x. So minus x minus x. So it is what? Minus 2x. Are you able to understood? So in the first, f of x is 0 and g of x is minus 2x. F of x is 0 and g of x is what? Minus 2x. So with this fx and gx, let us find both g composition f and f composition g. G composition f of x, that is g of f of x. G of, what is f of x? 0. Substitute that 0 in g, minus 2 into 0. So the answer is what? 0 only. Now we find f composition g of x, that is f of g of x, that is f of, what is g of x? Minus 2x. Substitute this minus 2x in f. What is f? 0. So nothing to substitute. If x is there, you put this value, right? So in all the values, zeros, right? So hope you understood. Because modulus x is there, you have to do in two cases. Now see the next question. Very simple question only. So first one, prove that f plus g composition h equal to what they asked us to prove. F composition h plus g composition h. So okay, now please listen here. So we have to prove this. So to find f composition g, what we do? F composition g of x we take, right? Okay, here also same thing. So what I'm going to do, f plus g composition h of x, that is f plus g of h of x. Okay, so f composition g means of x means f of g of x. We take that part first, right? So here h is here, so you take what? H of x. Okay, we take h of x. So now this you can split into two. F of h of x plus g of h of x. F of h of x means it is f composition h of x. That only you write f of h of x, right? G of h of x means g composition h of x. So in both the cases, x you take, just to put outside, you can write F composition H plus G composition H. See how we have started. In both the cases, you remove that x. So what can you say? So this implies F plus G composition H equal to F composition H plus G composition H. Okay, it's a very simple proof, but write and practice. Otherwise, you'll have a doubt whether it write like this or that. So that's a proof. Now, second part, what they ask here, what can you say about F composition G plus H? F composition G plus H. Now, let us see same method. F composition G plus H. This is for the second part. Of X. Same method only. For the second one, you give that X first, right? So, for that part. So, what do you write? F of G plus H of X. Hope you understood this step. So, that is F of. So, G plus H of X means it is G of X plus H of X. So, this can be written as F of G of X plus F of H of X. F of G of X means F composition G, right, of X. Plus F of H of X is F composition H of X. In both the cases, you take that X outside, F composition G plus F composition H. So you can say leave that X. So what's your answer? F composition G plus H equal to F composition G plus F composition H. Okay, this is the answer for this one. Now we go for the next question. It's a very simple question. The weight of the muscles of a man is a function of his body weight X. X stands for body weight. Can be expressed as Wx. W stands for weight. Wx equal to 0.35x. Determine the domain. So they asked to find just one line on this 1 mark question, right? Domain they asked. What values you can give for x? That's the question. Suppose a question say y equal to 7x. Y equal to 7x. If they ask what's the domain, what we see? We see for what x values the function exists. For that we see the denominator. If there is some denominator, it should not be 0. If there is a denominator, there is some constant, means okay. What is the domain? We say R. R minus infinity to plus infinity. It's like that only, right? 0.35x. For any value of x, the function exists. But here x stands for body weight. So it cannot give any negative number. Body weight, you cannot take even 0, right? So domain means here x must be greater than 0, right? Otherwise, if it is an ordinary linear function, you say minus infinity plus it can take negative values, it can be 0 because there is no denominator, right? But here x stands for body weight. Body weight cannot be negative, it cannot be even 0. So the domain is greater than 0. Don't take greater than or equal 0. Okay, so the open interval. Greater than 0 means 0 to till the end. It goes up to infinity, you can give. Okay, so this is the domain. Now see the next question. The distance of an object falling is an equation of time t and can be expressed as, so s is the distance, okay, distance in time t is equal to minus 16t square. Okay, this is one function given. Graph the function and determine if it is 1 to 1. So we have to check it is 1 1 or not. Okay, let us see. So to check 1 1, some method you know, f of a equal to f of b implies a equal to b. Then you say it is 1 1, right? That part you can check it. But they asked to draw the graph. So square is there. It's a quadratic graph. In 10th standard you would have studied y equal to x square minus 5x plus 6. You know the graph. It's a parabola, right? Open upward parabola. But if x square sign is minus, same parabola, inverted one, it will be getting, you will be getting something like this. It is looks like that one, you know, s of t. It is looks like y equal to minus 16x square. So it will be an inverted parabola like that. Okay, now let us see. So to draw a rough diagram, so what we do here, we take some values. Like 10th standard, you take from -4, -3, -2, -1. You take a series because 8 mark, right? Okay, but now it's maybe a 2 mark or 3 mark. Sometimes they will give graph, sometimes they won't give graph sheet. You have to draw in the ordinary paper only. Draw using scale, you mark some measurements and all. Okay, no need to take exact measures and all. Your rough diagram, they give mark. But see that you're not making mistake. So first we draw a table for this. For x and y, instead of x and y, here it is t and s, right? First, for time, you can't give negative values because time cannot be negative. So you can't start like -3, -2, nothing. So 0 you give. For time 0, if you give 0 in any number, it is 0. Give 1, 1 square is 1. 1 into -16, -16. You give 2, 2 square. 2 square is 4, right? 4 into -16, -64, right? If you want, you give 3, 3 square is 9. So -16 into 9, 144, it goes on like that, okay? So it's a parabola, but you are going to get only one side. So roughly plot the points. 0, 0, 0. So this point is 0, 0. Then 1 -16. When you take 1, here -16, somewhere the fourth quadrant, right? 1 -16. Then 2, it is 64. -64. When it is 3, -144. So you will be getting the curve like this, okay? You will be getting some parabola like this, one side, okay? Actually, other side should be like this, but since there is no negative values, you are not getting that part, okay? So the diagram is, you have to draw like this, okay? So plot the points roughly, and it should be a parabola. So you can draw a rough diagram, okay? So points you plot, you cannot plot up to 16 and all, right? So here you mark 1, 2, 3, some points. Here, say -16, 0, 0 only. Next one is -16. Then some 64, right? 64, it won't be a line, it will be a curve. You plot the points and draw, you will be getting a parabola like this, okay? But actual parabola, if you see, it will be like this in two sides, but the left side you can't take, only the right side part, okay? So because here x and y, instead of x and y, we have what? T and s. So now second, but there is one more part is there. Determine graph, okay, graph part over. So we have to check it is 1 to 1. So we have to check the function is what, 1, 1 or not. So what's the function given here? S of t equal to -16 t square. S of t equal to -16 t square. So what we do here, normally we take f of a equal to f of b like that. So here we take s of two values, s of t1 equal to s of t2. Then you try to prove t1 equal to t2. If you are able to prove t1 equal to t2, it's over. It is 1, 1. S of t1, what is S of t1? -16 t1 square equal to S of t2 -16 t2 square. Change the sign throughout. 16 t1 square is equal to 16 t2 square. Divide 16. T1 square equal to t2 square, right? Take square root. So t1 is equal to plus or minus t2, but t2 cannot be negative. Why? Time. T1, T2, everything what? Time. So time cannot be negative. So only possibility T1 is equal to what? T2. So f of T1, S of T1 equal to S of T2 implies T1 equal to T2. Therefore, you can say the function is what? 1, 1. Therefore, it is 1 to 1. So let's go for the next question. The total cost of airfare on a given route is comprised of the base cost C and the fuel cost S. So base cost, that is C, plus the fuel cost, fuel charge, that is S, together only what? The total cost. Total cost is base cost plus fuel cost, okay. Now, C and S are functions of M. M stands for miles. Okay. C of M, that is the base cost. C of M, they given us what? 0.4 M plus 50. This is C of M, base cost. S of M, that is the fuel cost, is 0.03 M, right? Determine the function of the total cost. So total cost equal to, just to add both, right? Total cost is equal to add both base cost and the fuel cost. Such a simple thing. If there is any like term, you add it. So first one is like term, right? 0.4 M, first and last. 0.03 M, so you are getting 0.43 M plus 50. So this is the answer for the first part. And see the second part. And find the airfare for flying 1600 miles. Suppose a person is flying 1600 miles, how much he has to pay? So instead of M, you put 1600. Okay, so put M equal to 1600. So the total cost equal to 0.43 into 1600 plus 50. The calculation part, you do that. When you multiply these two, you will get 688 plus 50, and your answer is rupees 738. Okay, so the calculation, addition, multiplication, all you know. Now let's go for the next question. A salesperson whose annual earning can be represented by the function a of x equal to 30,000 plus 0.04x, where x is the rupee value of the merchandise he sells. His son is also in sales and his earning is represented by S of x. 25,000 plus 0.05x. So what they asked, the total sale they asked, right? So what they asked here, A plus S of x. So A of x, S of x together, just add it. F plus G of x, F of x plus G of x, same thing here. So you write A of x plus S of x, right? So both you have to add it. So already written. If you want, you substitute and add. So like terms, you add these two. So 55,000, right? 55,000 plus x terms 0.04 plus 0.05, that is 0.09x, right? That's all. That's the answer for the first part. And determine the total family income if they sell rupees 1 crore 50 lakhs, right? Worth merchandise. So when x is equal to, so that's what you have to find. When x equal to 1 crore 50 lakhs. So you substitute here. So family income. Family income means both their incomes you have to add it, okay? So 55,000 plus 0.09 into x, 1 crore 50 lakhs. So first one 55,000 you write as it is. So when you multiply these two, you will get, so 2-digit shifting. So 13 lakhs 50,000. Okay, so you add it, you will get 14 lakhs 5,000. Okay, so check the calculation part. So multiplication, addition only, so do carefully. Okay, so very simple question. Now let's go for the next question. Question number 17. A function for exchanging American dollar to Singapore dollar. For that there is a function f of x. So f is a function which converts American dollar to Singapore dollar. And how the conversion takes place, f of x equal to 1.23x. Okay, so here x is in American dollars. American dollar. Suppose 10 American dollar means for x you put 10, 1.23 in 10, like that you can do that. Okay, and there is one more function. On the same day, the function for exchanging Singapore dollar to Indian rupee. So for that they are using the function g, and how it's convert g of, okay, instead of x they take y. G of y equal to 50.50y. So y is in Singapore dollar. If you multiply by 50.50, it will be converted into Indian rupees. Okay, so American dollar to Singapore dollar, then Singapore dollar to Indian rupee. American dollar to Singapore dollar, we have to use the function F. Singapore dollar to Indian rupee, you have to use the function what? G, right? What they asked here, write a function which will give the exchange rate of American dollar in Indian rupee. So directly we want to convert. This is one way, American dollar to Singapore dollar, then Singapore dollar to Indian rupee. Now we want a function which converts directly American dollar to Indian rupee. So how to do that? So here the main problem is American dollar to Indian rupee. Whether you have to take F composition G or G composition F. Listen very carefully. American dollar is given. We have to convert it into what? Indian rupee. So what do you do first? American dollar, you convert it into what? Singapore dollar. So for that, which function you use? F you have to use first. F you have to use first. It doesn't mean write F first. No. If you want to do F first, you write F of x here. That answer, you have to apply what? G. So G of F of x. Okay, so first you have to, F of x should take place. That is American dollar should be converted into Singapore dollar. Then give that to G. What is the work of G? G converts Singapore dollar to Indian rupee. So F of x only you have to do first. So it doesn't mean F composition G. It is G composition F. Okay. G of F of x. So you are supposed to find G composition F of x. So that is G of F of x. Composition function, you know, G of F of x. What is F of x? 1.23 into x. So give this value in what? This value to G. What is G? 50.50. 50.50 of y, that is 1.23x. Now again the multiplication that you do carefully. So this will be your answer. So this function converts directly American dollar to Indian rupee. Now the next question. Listen carefully. Question only looks little lengthy one. Try to understand matter of just 2 lines, 3 lines. Very simple concept. Listen here. The owner of a small restaurant can prepare a particular meal with the cost price of rupees 100. So cost price of a meal, rupees 100. He estimates that if the menu price, that is the selling price, of the meal is X rupee. So selling price of a meal, rupees X. Then the number of customers who will order the meal at the price in the evening is given by. So number of customers is given by d of x equal to 200 minus x. Okay, number of customers is what? 200 minus x. So can you tell me total cost price? Listen, total cost price is for one meal, how much cost? 100 rupees. Suppose 5 meal means 5 into 100. You suppose there are 10 customers, you multiply by 10. How many customers are here? 200 minus x. So it is 200 minus x into 100, right? So this is the total cost price. This much is his expenditure. Then selling price, for that is total selling price. For one meal, the selling price is x. So number of customers, suppose 20 customers means 20 into x. Okay, total selling price. So here 200 minus x customers, so 200 minus x into x. So now you know total selling price and cost price. What they asked? Total cost, express his day revenue. So day revenue means total selling price. That is his day revenue. Totally how much he gets? 200 minus x into x. If you want, you can multiply. So here you can multiply and write. So 200x minus x square. So day revenue. Next they asked total cost. Total cost already got it. Anyway, write them again. Total cost is equal to 200 minus x into 100. That also, if you want, you can multiply by 100. So you can expand it. 20,000 minus 100x, right? Then finally they asked to find the profit, right? They asked to find the profit also. So only that is the only thing you need here. The formula for profit, SP minus CP. You would have studied in the lower classes, right? Selling price minus cost price. Or you can say revenue minus cost. Revenue minus cost. What's the total revenue? 200x minus x square. Minus of cost. Minus of this. So change the sign. Minus 20,000 minus minus. So it becomes plus 100x. Like terms, positive terms are writing first. So 300x minus x square minus 20,000. Okay, that's all. Now let's go for the next question. The formula for converting Fahrenheit to Celsius, there is a formula. So y equal to 5x by 9 minus 160 by 9. Better we take 9 as LCM, right? So 5x minus 160. Okay, this is the formula to convert Fahrenheit to Celsius. Okay. Find the inverse of this function. Determine whether the inverse is also a function. Okay, so first they asked to find the inverse. You know how to find the inverse. So what you're getting here, y equal to 5x minus 160 by 9. From here you find what? X. So cross multiply 9y equal to 5x minus 160. So 5x equal to 9y plus 160, or x is equal to 9y plus 160 by 5. Or you put 1 by 5. Okay, by 5. Okay, this is x value. Therefore, inverse of the function f inverse of x is, this is the answer, but instead of y you put x. That's what we studied earlier, right? So what do you get here? 9x plus 160 by 5. So this is the inverse. Now the question is, check whether inverse is also a function. Last class we studied, no? Function is invertible or not and all. So here f of x and g of y we take. F of x is what? The given function. 5x minus 160 by 9. 5x plus 160 by 9. This is f of x. 5x minus only. 5x minus 160 by 9. And g of y, the inverse function, you use y here. 9y plus 160 by 5. Okay, so this is g of y. Now we have to find what? F composition g. F of x, g of y. The previous video I taught, hope you remember. G of y, right? So F composition g of y, your answer should be y. That is I of y, right? So that is f of g of y. That is f of, what is g of y? 9y plus 160 by 5. Substitute this value in f. What is f? 5x minus 160 by 9. So in the bracket you put 9y plus 160 by 5. 5 and 5 cancel. You are getting 9y plus 160 minus 160 by 9. Plus 160 minus 160 cancel. You are getting 9y by 9. 9 cancel y. So that is I of y, right? This is not enough. You do the other part also. This is F composition G, right? You find G composition F. F is there. Second, F of x, right? Of x. So G of F of x. That is G of, what is F of x? 5x minus 160 by 9. So put this value in G. What is G? 9y plus 160 by 5. Instead of, in the bracket you write 5x minus 160 by 9. So again cancel this 9. You are getting 5x minus 160 plus 160 by 5. 160 get cancelled. You are getting 5x by 5. 5 cancel. You are getting x. That is I of x. Okay, so both the values you got it. So you can say, check whether the inverse is also a function. Therefore, inverse is also a function because both are bijection. Okay, so both are bijections. Bijections means they are one and on two, so definitely it's a function only. Okay, just one more question. See this question. A simple chipper takes the number, a number and codes it using the function f of x equal to 3x minus 4. F of x equal to 3x minus 4. Find the inverse of the function. So what do you do? Y equal to 3x minus 4. 3x equal to y plus 4, or x is equal to y plus 4 by 3. Okay, so find the inverse of function. So f inverse of x equal to, instead of y you put x plus 4 by 3. So okay, the first part is over. Find the inverse of the function. Determine whether the inverse also a function. So for that you know the method, right? So determine whether the inverse is also a function. So what do? You take this as g of y. G of y equal to y plus 4 by 3, right? Now you know f composition g of y. You will get y. That part I want you to do that, okay? And f composition, sorry, g composition f. G composition f of x. Easily you can do that. You can prove it is equal to xi of x. So they are invertible. So they are bijections, both f and g. So the inverse function is inverse of the function. It is a function. Okay, it is a function. Now verify the symmetrical property about the line y equal to x. Verify the symmetrical property. What is symmetrical property? You know, symmetric means what you have in the. See, suppose they are giving something like this. Suppose you have some curve like this, below also like this. Then we say this is symmetric about x-axis. Suppose if you have some portion like this, same way you have the left side also something like the same form. Then you say it is symmetric about y-axis. So this is a symmetric property, the higher class we study in detail. So here, symmetric about the line y equal to x. Y equal to x means, see, y equal to x. So you can draw a small table, x and y. 0, y equal to x, right? So when I put x equal to 0, y also 0. When I put x equal to 1, y also 1, because both are equal, x equal to y. 2, 2. So if you plot the points 0, 0, 1, 1, 2, 2, you will be getting a line like this. Okay, this line is what? Y equal to x. So we have to prove that which one? F of x and the inverse function, that we take it as g of x. Okay, so both the functions you have to draw, you will get two lines. They are symmetric about this. Suppose if we have one like this, another one should be something like this. Okay, so then what portion you have here? Similar portion you have here. Here whatever you have, same thing you have here also. Okay, so then we say it is symmetric. So only thing, graph, 3 lines you have to draw. One line I said y equal to x is a line. Another 2 lines, one is for fx, another one is for g of x. G of x means inverse function. Fx equal to 3x minus 4. Fx equal to 3x minus 4. You take it as y equal to 3x minus 4. In the lower classes you studied how to draw a line. You find at least minimum 2 or 3 points. Say x and y. So give some value. Say if you take x equal to 0. When you take x equal to 0, y equal to what? Minus 4. Suppose I am taking x equal to 2. 3 2s are 6. 6 minus 4, 2. 2 2s. Even 2 points enough. If you want, you find one more. Plot the point, draw a line. So that line is y equal to r fx. That is fx. Okay. Then you take the other function, g of x. G of x is the inverse function. Inverse function. This is inverse function. F inverse x, right? X plus 4 by 3. X plus 4 by 3. Take that as y. Y equal to x plus 4 by 3. For that also you draw a line. That is also a line, right? Give some values. X value, y value. So when you put 2, when I put 2, 2 plus 4, 6. 6 by 3 it is 2, right? You can give some other value because denominator is what? 3. So it should be divisible by 3. Such a way you can give some number. Say for you can put 5. So if I give 5, 5 plus 4 is what? 9. 9 by 3 is 3. So even plot 2. If you want to take one more point, plot it. You will get the lines. Then y equal to x is the third line. Okay, so if you plot all these lines, you will be getting like this. This is the line for fx. All of you know how to draw the graph. The first line, y equal to 3x minus 4. This is the second one, f inverse x. That is y equal to x plus 4 by 3. One is the red line, that one, another one is this blue one, and y equal to x is this line. Okay, y equal to x. So now we see it is symmetric because this portion are similar, right? Same way here, this portion and this portion. So it is symmetric only. So the symmetric property is satisfied. Finally, you can say, just draw the graph. So in the rough diagram only, graph only you are going to draw. So using pencil scale, draw neatly. So small numbers only you can take very easily. and say from the graph, symmetrical property about the line y equal to x. Property about the line y equal to x is verified, or you can say is proved. So very simple only, but it takes some time. So mainly we studied how to find inverse. Okay, that's the main thing. Other things are very simple things only. Just to go through the example sums also. We'll continue in the next class.